when we process the data, it becomes information. Okay, so if we add context to the data set, it becomes information. Okay, so for example, a list of date is a data, but when we add that these are the holiday, these dates are holiday, it becomes the information. Okay, so earlier we were having small data sets. Okay, so for example, sales records, customer database, small and medium companies, hundreds and thousands of records were there. And then typical tools were personal computer, Excel, R, other basic statistics software, only mean, median, mode kind of thing. Okay, so analytical method was simple statistics. So the size of the small data was in megabytes. Okay, so this I'm talking about long back. Then the era of this large data came, and the order of this large data is gigabyte to terabytes. Okay, so people were having database management system, then millions of record, mostly structured data sets were stored. We were having this server and workstation kind of structure. Okay, so we can access multiple, client can access a particular server, get the solutions. And the methods were advanced statistics, business intelligence, data mining. So data warehousing, mining, all these concepts came during this era of large data. People have also started working with the machine learning kind of algorithm, and then they were analyzing these type of data set. Okay, then this era of big data came. So it is the order of terabyte to petabyte to even much more. Okay, and that is the current era. So what is happening everywhere? People have started collecting the data set. Okay, even if you check your mobile phone, always you'll find out that your email, Google Mail, and your even mobile phone, every time you'll find out your memories are full. Why? Because everything you are storing, you are capturing lots of picture, you are storing lots of data set, you are downloading lots of data set. Whatever important you see, you just store them. Okay, so what is happening, every one of us have started collecting the data set, and as well as all the companies, because companies have understood that if they are having the lots of data sets, then they can actually plan for future, they can convert that data into money. Okay, so customer interaction, social media, mobile, multimedia, video, image, free text. So earlier we were talking about the structural data set. Now we are talking about unstructured data set. Whatever is there, we should store them. Okay, so format is a secondary thing. So over millions of record distributed. So earlier we were running our machine learning algorithm in a database, and now if we have to store all these data sets, so we cannot store all of them at one place. So what we have to do, we have to store all these data set at different locations, different systems. Okay, and that's why we have to use distributed systems. Okay, so earlier we were having machine learning algorithm that can work in a single system, and now we have to scale up these machine learning algorithm, artificial intelligence methods, so that they can collect data set from different distributed environment and then process them and then produce these solutions. Okay, so that's what is the distributed computing came. So we have also scaled up all machine learning algorithms so that they can work at different places, and then at combined they can produce some result. Okay. And then this concept of map reduced distributed system, all these came. Okay. And then we have upgraded our machine learning algorithm in form of deep learning and now the generative AI. Okay. So if you see right hand side, there is a data table A, B, and Y. Okay. So if we consider A and B as the input, Y as the output, so the values are 0, 0, 0, 1, 1, 0, and 1, 1. And the output is 0, 1, 1, 0. So if you remember exclusive or logic gate, you'll find out there's a truth table for that. Okay, but exclusive or is considered to be a benchmark data for machine learning algorithm, and that's why I have taken this example. So this is a kind of data set in which we want to perform some application of machine learning so that we can classify two classes like class 0 and class 1. Okay, so if you see inputs are same, output is 0, otherwise output is 1. Okay, so what is the type of data set? This is a data set which is best suitable for supervised learning algorithms. So in machine learning there are two types of learning algorithm. One is supervised learning algorithm, second one is the unsupervised learning algorithm. So this type of data set is best suitable for supervised learning algorithm, in which there is an input data set and followed by output classes. Okay. So if we are giving you a data set like zero point 0.2 and zero point 0.7, so you can predict that the class will be class 1. Okay, because the inputs are different, so class is 1. Now suppose if we consider that A, B and Y all are inputs, there is no output class in this. Okay, you see what is happening. So with respect to time, we have taken the amplitude of anything. Okay, and what is happening, it is changing over period of time. Okay, and based on that we are making some kind of decision. So in today's session we are more interested toward dealing these type of data set, which is known as time series data set, because x-axis is the time, y-axis is the amplitude. Time series data set is considered to be very chaotic in nature, very random in nature, and that's why modeling and prediction for time series data set becomes very difficult problem. Okay, coming to the examples of time series. So time series are observations on quantity that is random variable collected sequentially with respect to time. So like weather, if you see the weather since morning, okay, it's a sunny weather, very hot, temperature maybe around 40 degree, 42 degree. Okay. So now if somebody asks you to predict what will be the temperature after 1 hour, you can immediately predict like what will be the temperature after 1 hour. Okay. So based on today's data, based on yesterday data, based on day before yesterday's data, and then we can predict for future values. Okay. And that's why we are collecting these type of data sets sequentially with respect to time. It is not like randomly we are collecting. Okay. So time series are observation on a quantity random variables collected sequentially with respect to time. Other examples, finance and economics, Sensec data set, price of bitcoins. Okay. So every time you can find out that people are making AI models so that they can use it for prediction of the market, stock market. Environmental and natural science, I have already taken the example of uh, the weather condition. Okay, so pressure, temperature, precipitation, rain, seismic signals, all these are examples of time series data set from environment. Engineering, speech signal, like I'm speaking in this classroom, so my signal, if you collect this, it is a time series signal because with respect to time there will be amplitude only. Electrical power load, the sequence of queries in a search engine or the frequency of query over time. If we see the medical data set, neuroscience data set, so brain activity measured by EEG. So if we are collecting this EEG signal, you must have seen with the doctors that they are looking like a time series signal. If we are collecting the fMRI or other techniques, if we see the example of a spread of COVID-19, which had happened during the COVID period, okay, so all these can be considered as the time series data set because we are collecting the data set sequentially with respect to time. And what is our purpose? Our purpose is to model this type of data set so that we can use it for further prediction for future values. Okay. If we see the genetics, so macro array data for cancer detection, security, event occurrences in a log over time, internet web traffic, CPU uses, intrusion detection, vulnerability, etc. Like you are monitoring your system CPU uses, and you are finding out that during the night time the CPU usages become more. Okay, so the percentage of CPU uses become more. So what does it mean? Somebody else is utilizing your computer system CPU. Okay, so that is also possible. So that is known as cryptojacking. Okay, there is a term known as cryptojacking. If somebody else is utilizing your computing power, and then at the same time, why they are utilizing your computing power? Because you are using your own electricity. They will not pay for the electricity, they will not pay for the CPU, but they will utilize your system, okay, for solving bigger problems. So these are the examples of time series data set. You see SBI stock price, if we are considering a single stock market particular company data, so it will look like this. If there is a sale of a particular item in the market, you can see like this. There is an annual temperature data set. Okay. Then there is a internet traffic data set in bits from a private internet service provider. Okay. So it will look like something like this. So what is the formal definition of time series? So let omega fp be the probability space, t an index set, a real valued stochastic process is a real valued function x t omega, such that for each fix t belongs to capital T, x t omega is a random variable on omega fp. When the index set t corresponds to time indices, discrete or continuous, we'll call x t omega time series. For fixed t, x t omega is a random variable. For fixed omega, x t omega is a real valued function of t that is called the realization of time series. We typically suppress omega and write xt. So now onwards, we'll use this term xt for representing a time series data. So for discrete time series, the set of time indices are discrete, whereas for continuous, they are continuously representing scale between 0 to 1. So a time series is a observation. A time series is a series of observation xit. So now we have introduced another parameter, that is I. So earlier it was xt for representing a time series. Now we are mentioning xit. So it is called a univariate time series when I is equal to 1, and called multivariate time series when I is equal to or greater than 2. That's why we have introduced this term I. So now xit, I is equal to 1, it means xt is representing a univariate, means single column, single row data set, whereas if it is x2t, x3t, x4t, something like that, so we can say that it's a multivariate time series data. So modeling and analyzing a time series data is itself a difficult problem. And now we are talking about multiple time series data set together, and then we have to analyze that data. So it will become even more difficult problem. So multivariate time series analysis is used when one want to model and explain the interactions and co-movement among a group of time series variables. So it is not like that there is a single time series data set, we have to analyze that data set, we have to model that data set, but at the same time we should consider other time series data set also in order to make some decision. Okay, and that's why we are talking about the interaction and co-movement among a group of time series variable. Okay, so left hand side is the example of a univariate time series data, whereas right hand side is the example of multivariate time series data. So here you can see that there are multiple time series we have to study together in order to make some decision. So why working with time series is so difficult? Why we say that it's a difficult problem? So many of the process creates large amount of data in a small time frame. For example, 1 hour of ECG data is 1 GB. So electrocardiogram, if we are recording, so it will become 1 GB for 1 hour. Typical weblog, 5 GB per week. Space shuttle database, 200 GB and growing. Macho database, that is astronomical database, 3 TB updated with 3 GB a day. So you can see how big is this time series data. And right hand side, if you remember this Chandrayaan, so Chandrayaan, there were multiple sensors together and people were collecting real-time data set from the Chandrayaan, and then they were analyzing. So it is again a time series data set. Okay. So since most of the data set lives on the disk, we have to find out some way so that we can compress this data set, because we cannot work with all the data set. Like suppose you are using some camera at your home, and then you are seeing who else, what are the people who are going uh, towards your home. So what will happen if you are collecting since morning till evening? Your whole memory will be full. So what you can do, you can do some kind of sampling. Okay, you cannot store all the data sets since morning till evening, but you can store some of the intermediate values. So that's why we'll see the methods in order to represent these time series data set, so that we can also compress them in some manner. So there are different data handling problems, like different data formats, different sampling rates, noise, missing values. So I'm not taking all these examples. Okay. So, what are the major application areas of time series? Is the visualization. You see the right hand side. Doctor normally sees this type of pattern, and then based on that, they decide whether a particular person is having some kind of heart related problem or not. Okay, some values are coming. We can use them for clustering. We can use them for classification, pattern recognition, forecasting, rule discovery, motive discovery, query by content, novelty detection, and many more. So you can see that there are enormous application of time series data set. Okay. So what is motive discovery? Motive discovery means if some similar type of pattern is arising after some time. Okay. So like a period of first wave of COVID, period of second wave of COVID. So you'll find out similarity during those periods. Okay. So now we'll see some of the methods which we can use in order to represent time series data. So the different representations of time series are classified into three categories. One is the temporal representation. Keep a temporal point of view of the data set. So what is temporal representation? We are directly just collecting the data set of time series with respect to time and we are storing it as it is. Then there is a spectral representation in which what we are doing, we are converting this time domain signal to the frequency domain signal and then we are storing them. And then the third representation is apply some other transformation that do not fit into first two categories. Okay, and we will see that now. So now suppose if there is a time series data set, how we can store them? We should first what we should do, we should divide the time series into small blocks and then we should take average of those blocks. And you see y axis, we have created different kinds of intervals. Okay, so like the value is from minus zero point 0.5 to plus zero point 0.5, we'll use symbol B. Zero point 0.5 to 1.5 will use symbol C, and from minus 1.5 to minus zero point 0.5 will use symbol A. So this method is known as symbolic representation method. Okay, so instead of using a time series, double values, float values, we'll use symbols for representing the time series. Okay. So now suppose if there is a time series, we have divided into suppose block of 10 values, and then we are taking the average, and then we are mapping with the y-axis because there are three symbols only. Will appropriately min to max. We can actually create three kinds of interval, and then we can assign the values of these symbols. Okay. So like the first, you see the first 10 values, they are belonging to the range of zero point 0.5 to 1.5, the average. So that's why we are using this symbol C for this first 10 values. Second 10 values, we are using symbol B. So now what we'll do, instead of storing 10 values, we'll store only one symbol, that is C, B, C, C, B, A, A, B. So that is the reduced size of the time series. So later on, you should try at your home that if you are storing all the double values, decimal values, and then if we are comparing for storing these symbols into the memory, which one will take lesser space? Okay. So this is the symbolic representation method. So what we are doing, we are dividing the whole time series into different blocks. Every block we are taking the average, and then average we are mapping with different symbols. So like in this particular case, we have taken three symbols. Now suppose you want 5 symbols, you want 10 symbols, so you can actually appropriately create different intervals and then assign those intervals. Okay, so it can be A, B, C, D, E, F, G, it can be anything else. Okay, so people said that in place of taking this average value or mean value, why not to consider the min and max as well? Okay, so then people have given the another extended method of the symbolic representation method, and that is known as extended symbolic aggregate representation method. Okay, and what is that? Now every block will use three terms to define. One is the min, second one is the mid, average, and third one is the maximum. Okay, and then it means there will be three symbols for representing any block. So I have to ask that we can take a block of 10 values, you can take block of 100 values, you can take block of 50 values. So as per the need, we can divide the whole data set. Okay, so that method is known as extended symbolic aggregate representation. So now earlier, if we were having the decimal values, so we can use Euclidean distance in order to find out if some new time series is closer to which time series. Okay, so like values will be there, we can find out Euclidean distance, square root x2 minus x1 whole square, y2 minus 1 whole square, and so on. But in the case of symbolic representation method, we cannot use these kind of Euclidean distance based method. Then suppose what we can do, we can use suppose Hamming distance based method. Okay, so what is the Hamming distance based method? If symbols are matching, we'll take the values, otherwise we'll take zero values, and whatever is the sum is the Hamming distance. So like there are two string one and string two, A B C D E F G. Then string two is B C D E F G H. Okay, and then we are comparing whether A and B are same. Yes, no. If no, then value is one. If yes, then value is zero. Okay, so having distance is 7. Otherwise, distance was 0. So what does it mean? If we have to find out similarity between two things, we have to compute distance between them. If the distance value is more, it means similarity is less. If the distance value is less, it means similarity is more. This is another bag of word method. Okay, so every slide, if you see, you'll find out some link also, so that you can implement that particular content, whatever is mentioned at different slide numbers. Okay, so like here you see there is a link motive.github.io. Okay, so you can get the code of whatever I'm speaking in this particular slide. So like this is another example, like there is a time series, M time series data set, and then we are using three symbols together in order to represent that time series. So like ABC, AC, ACA, ABC, BBB, CCC, something like that. So we can create all kind of these kind of symbolic representation, and then we can use different methods in order to check if suppose new time series comes, it will belong to which particular class. Okay, so it is a term frequency, inverse term frequency based method is there. So understanding time series modeling difficulty, why we say that it is a difficult problem. So you see left hand side chart. So what is happening here, left hand side, there is a temperature. Okay, so even you see nowadays it's very hot during the daytime. So what people will do, people will not go to the market, they will go in either in morning or evening to buy something. Okay, so left hand side you see there is a temperature based sales, okay, of a particular company. So for a given temperature there is a sale. Now you see there is a high temperature. If the temperature is high, sale is more. So what does it mean? We are talking about Russia kind of country. Okay, so if temperature is high, people will find out good weather, they will go outside, go to the shopping, and then they will purchase. So what is happening, for a given value fx we are only getting one value of y. Now you see right hand side, if you remember this type of curve, it is known as hysteresis curve. In class 12 you must have seen this type of plot. So what is happening in this particular curve? So like suppose what is the value at x is equal to 1000. At x is equal to 1000, value of y is 0. Okay. X is equal to minus 1000, again value of y is 0. Okay. Now suppose if I am taking x is equal to 1500, then what will be the value of y? So how to calculate that? We have to first project a vertical line on this particular graph. If we are projecting a vertical line at 1500, what will happen? It will cut the graph at two places, one at the lower level, second one as the upper level. Okay, so it means for a given value of x there are two values of y. So if there is a single value of input, if we are having multiple values of output, how can we make any model and how can we do prediction? Okay, and that's why this time series data set is considered to be very difficult problem, because for a given value of x it can produce multiple n number of output values. Okay, because we cannot know what will happen to the weather. Okay, we can give some kind of probability. Now we are able to better predict the market as well, weather as well. Okay, but still there are lots of uncertainties associated with it. So now for 1500, what should be the value of y? So how to calculate that? We should see whether this particular curve is crossing that particular perpendicular line. Whether we should consider lower value of line or we should consider upper value of line. Can anyone answer this question? The question is, at value x is equal to 1500, with what should be its value? What should be the value of y? Whether it should be lower value of y or the higher value of y. Like suppose lower it is cutting at 0.200 and upper it is cutting at 350. So what should be the value of y? So what we can say, for a given value of x, if we want to predict the value of y, that whether it will be a lower value of y or the higher value of y, we cannot predict as it is from this data set. So what we should do, we should introduce historical information into the data set, and now we should be able to predict for the future values. So now suppose up till yesterday we were getting the lower side curve data set. So today if we have to predict, we'll say that we'll get the lower value of output. So that is 200. If we say we are getting up till yesterday the upper side of curve value, so we can predict that our model will predict the upper value of y, that is 350. Okay, so what does it mean? It means that if we are including the historical information into the system, the machine learning model, it will perform better and will produce appropriate classification outcome. Okay, so now how to make this historical data set so that history can also be part of the data set. Okay, so left hand side you see there is a data set with a single variable. Suppose temperature is there, pressure is there, or something else is there, some sensors are there. So you are collecting a continuous data set. Okay, so left hand side there is a single row or single column type of data set, and now what we are doing, we are copying them in a specific manner. So what is this copying? One row above, one row above, one row above. And now if we discard this upper triangle and lower triangle, what will happen? The in between middle part, we can consider that this particular data set is having three input and one output. So first, second, first, second, third data, day data is input and fourth day data is output. Then second, third, fourth day data is input, fifth day data is output, and so on. Okay, so this in this manner we are able to actually introduce the historical information into this data set. So in this example we have taken only one row above. You can take 7 rows above, you can take whatever you want. Okay, so we are discarding this upper triangle and lower triangle values because we cannot make them complete, and that's why we have taken only the middle part of the data set. Okay, so now in this data set, if suppose first, second, third is the input, fourth is the output, we can use any model for modeling this data set. Now suppose if we are having regression kind of method, then what we can do, we can actually add these uh, first day, second day, third day data set, and then we can predict for the fourth day data set. Okay. So we can predict for the fourth day data set. So now we'll see how we can model them. And before that, we should see different kind of database management system models. So there is a website known as dbengines.com. If you see this particular website, if you search for the database, you will get database like this. So graph database management system is there, time series database management system is there, and then there are multiple database management system. So this type of data set website is actually giving us the popularity of the data set. So now you see there is a graph database management system. The curve is at the top. So you can find out that there are lots of popularity of this data set. And second most important data set is this time series database management system. So why this graph database management system is gaining much of the popularity? Because nowadays you see there are lots of generative models and people are using graph dbms for modeling those kind of data set. But the second most important database management system is the time series database management system. Okay, so that is also very popular, and that's why you should know about it. So if we rank them, so from the same website, if we rank them, you'll find out that there are multiple database management system which can be used in order to model the time series data set. Okay, so this is the rank. You can go through the website and then you can work with them. So those who are interested in the database management system can actually look about all these kind of database management system related to the time series. Now coming to the applications, you must have seen this type of picture where people are utilizing drones, cameras, other sensors in order to monitor the particular farming land. Okay, so nowadays if you are near to Lucknow, so there is a Malihabad, people are utilizing these drones in order to monitor the mango trees, in order to spraying the insecticide, pesticide on the mango trees. Okay, People are also utilizing different kind of sensors so that they can also monitor the water level at the farming land. Okay, and then people have developed different kind of systems so that it can automatically water those particular area if there is a requirement of water. Okay, so we can do soil testing, we can manage this water kind of thing, like when it is required. All those kind of monitoring can be done. We can also use drone cameras in order to detect whether there is some disease in a plant, suppose. Okay, so particular crop is there, you can just run this drone and then it will capture the images, and then based on that it will detect whether there is some kind of disease in the leaves or not. Okay, so all these kind of problems related to the diseases, related to the water and other thing, we can actually monitor using different sensors. So this can be considered as the time series data set. Okay, so right hand side, if you see, there is a structure. You can find out at the farming land in India, it is very popular, but in abroad also. So what is happening, if some bird animals are coming and if they are seeing this kind of structure, then what they will understand, that there are some humans, and because some humans are there, they will not come to that particular farming land, they will run away. So in place of this type of system, if we can convert this in form of a camera, big drum, and then some kind of machine learning method which can actually detect if some birds are coming, animals are coming, then they can actually match the pattern, and then they can play a huge loud siren so that they can run away. Okay, so all these are the example of time series data set. Here you see there is a term mentioned, that is IoT, Internet of Things. So what we are doing, we are actually giving addresses to each and everything, and now the humans as well as the other non-humans, we are able to communicate with each other so that we can do proper monitoring. So this IoT also came in between, and that's why people are using different kind of sensor at different places, and then they are utilizing them in order to do different kind of monitoring, prediction, decision making. Okay, so this is the example of time series data, because with respect to time you are collecting all these kind of data set. Coming to the smart city kind of concept, so we are using multiple sensors and multiple things in order to make our cities smart cities. So there are multiple smart city projects are also happening. Concept of smart homes, so people are nowadays having cars also. Okay, so everything as also. Okay, so everything all together. So this is another example of time series. So this is another example of time series, that is artificial intelligence in municipal corporation Uttar Pradesh. The UP government, what they are doing, they are implementing this particular project, and we are in that group who are evaluating this whole solution so that it can be implemented at all the municipal corporation of Uttar Pradesh. So what currently they are doing, they are monitoring the garbage on the roadside, illegal hoardings, encroachments of street lights, stray animals, and pathholes. So in the initial phase, they are actually taking care of these kind of classes, six type of classes. So what is happening? They will monitor if all these kind of things are present, and then they will remove them. Okay. So how they are monitoring? They are again working with the time series kind of data set. So if there is a garbage with respect to time, because you are also mentioning the time, when you have seen the particular garbage at particular place along with the geolocation, then what will happen later on? They will send information to the respective team. That respective team will clean that garbage, and then next day you'll find out there is no garbage. Okay. So now with respect to time, you can actually monitor it. So they are utilizing other thing also. You must have heard about YOLO algorithm. So they are utilizing YOLO algorithm in order to detect particular object. You can also go through that. They are also looking for the stray animals. So if there are some stray animals on the road, they can monitor them, and then they can send them to the shelters. This is the example of healthcare. So suppose elderly peoples are there and they are wearing different sensor based clothes. So what will happen? Multiple sensors are there, and they can monitor, suppose, oxygen level, they can monitor the heart beats, they can monitor the rhythm of the heart, they can monitor the temperature, they can monitor other parameters also. Okay, and they are wearing this particular shirt, suppose, with sensors. So what will happen, based on multiple sensor values, the system will be able to predict whether the person is going to get some attack or not. If the person is going to get some attack, automatically system will send the information to the physician, the relative, as the ambulance, so that they can help that particular elderly person, so that the person can get the relief. Okay, and the life of that person can be saved. So this is very good example of multivariate time series data set, because you see there are multiple sensors, and based on that we have to collectively make the decision. And that's what I have mentioned when I was talking about the multivariate time series data set, that we have to see the co-movement of different time series together in order to make the decision. Okay, so link is there. This is another example of Tesla car. So you must have seen there is a no driver in this particular car, but still you can move from one place to another place. So what is happening at all around this, every side there are lots of sensors, and then inside a decision making system we can actually take care of the environment, and based on that decide how to go, what should be our speed, when to put a brake. Okay, all these kind of thing, and so that you can comfortably reach from one location to another. So this is another example of time series data set. This is cow on IoT platform, internet of thing. So what is happening, Microsoft has actually developed this kind of solution. And what exactly is this solution? You can see there is a pedometer kind of thing. So nowadays we are also using our mobile phone in order to count the number of footsteps we are taking every day. Okay, so it is related to our health monitoring. Similarly, we are using, or Microsoft is using this type of device for monitoring the health of a cow. So you can see there is a cow, and we can put this kind of device at the leg of cow. So what will happen, based on the footstep, farmer can actually decide when the cow will become in the heating state, so that she can produce child. Farmer can bring that particular cow for the artificial insemination, and then that cow can produce the child. Okay, so what is happening, so this is the actually data set, statistical data set, that when the cow becomes when the cow comes in the heating state, it becomes very difficult problem for the farmer to understand. Okay, so what happened, earlier without this particular system, the stress, we say that this term is stress, and this device is known as stress detection system for cattle. Okay, so if we have to, or farmer has to decide when the cow is in the heating state, it becomes very difficult. So earlier the stress detection rate was only 50%. So you can say just more than 50% time the farmer was able to understand cow is in the heating state, so that they can bring that particular cow for the artificial insemination, and she can produce childbirth. So pregnancy rate was 39%. Now, when they have started using this stress detection system for cattle, what they have observed, that now this stress detection rate is 95%. Okay, so almost 100%. And now the pregnancy rate is 67%. So up to 70% improvement in the cow production. Okay, so Fujitsu had actually designed this particular hardware. So Microsoft with Fujitsu, they have combined together all these ideas, and now they are monitoring the health of a cow, and especially the stress period. So what they have observed, that if they are able to correctly classify when the cow is in the heating state, they are going for the artificial insemination. Then what they have observed, that for first 8 hours, if they are doing this artificial insemination, so in that case the child will be probable female. So if they want female cow, so they can actually control the birth rate of male cow as well as female cow. And what they have observed, that at the, if they are going for artificial insemination after 8 hours, it is probably a male child. Okay, so they have also controlled this, like how many male they wanted and how many female they wanted. So the probability will be more for female if it is first 8 hours. So what they did, they have actually connected this device wirelessly to their internet, and then their system, When the cow is in the heating state, immediately they will send this information to the farmer's mobile, and mobile phone, immediately farmer will bring that cow for the artificial insemination. Now you see what is happening. This is a time series data set. Pedometer are being used in order to capture the number of footsteps. So when the cow comes into the heating state, the number of frequency increases. Okay, and that's why when the number of frequency increases, easily you can observe this data set right hand side, that number of frequency has been increased significantly. And whenever there is a significant increase in the footstep, it means cow is in special condition, and now farmer can take care of that particular cow. So what they have extended this particular problem, and then they have observed that they are able to predict around 7 to 8 type of diseases present in the cow. So that's what is the gain. It is not only for the stress, but it is also for the health detection, health status detection of the cows as well. Okay, so they can identify 7 to 8 type diseases as well. So they have tested this system for horses also, and for other animals also. So we are also doing similar kind of work here in India. So you can see there is a Gaushala near to our place in Allahabad. So what is happening? You must have seen that municipal corporation people, wherever they are finding out these stray animals, they are just sending them to these type of shelters. So everywhere you will find out lots of shelters, and government is giving around 30 rupees per cow for taking care of that particular cow. So now it is 50 rupees per day per cow. Okay, so now the person associated with these kind of shelters are taking care of these cows. So what is happening? They are not going outside. They are all the time inside that shelter. Many times they are not getting green vegetables, green food for them. And then what is happening? That they become weak, and at the end they normally die. Okay, so whenever there are cows, they are going to the shelter, they are going for the death only. Okay, so there are different people associated with these type of gaushalas. So you see there is a doctor also associated with it. You see there is a one male cow, and what is happening? This particular cow don't have eyes. Okay, but it has some kind of disease. So doctor is taking care of that particular cow. Okay, so we are also using cameras in order to monitor these gaushalas, and then based on the movement of the cows, based on the behavior of the cows, we are able to detect whether a cow is in the good health or not. Okay, if not, then we are trying to classify them. So this project is already going on. You see, there is another example of AI toothbrush. Okay, so now you see what is happening. It is not like I'm promoting Oral B, but this video was available, so I have taken this video. So now you see this type of brushing can be used in order to detect how properly you have brushed your teeth. Okay, whether you have put more pressure at some places where you have not taken care it properly. So now you see how people are converting ideas into the product. Okay, and then this is again a time series kind of model, and the cost of this toothbrush is around 15 to 18,000 rupees. So it is not like a cheaper one. Okay, 15 to 18 rupees is 15,000 to 18,000 rupees. Okay, so you see there is a simple idea, but you can convert them into the product. There are other examples also for time series data set, like ONGC gas pipeline explosion. You must have heard that lots of people were died. So if we were having IoT kind of system, and then we can early predict if there is a huge rise in the temperature, or if there is a possibility of explosion, so we can actually detect and save lots of lives of the people. Okay, so these are different examples of time series. This is another example of time series. There is a code written inside below this. So there are leaves, and these leaves you can convert them in form of a time series. Okay, so right hand side you can see there are different leaf sizes. Uh, Time series representation of the images. Okay, leaf images. So it means we can solve image processing problem also using time series analysis. Okay, so how to convert these leaf into these time series? The code is there. Like there is a sweet neem leaf, sour neem leaf. So we cannot detect it as it is, but if we are using image processing, so we can easily solve this problem. So we can convert this time series into image processing problem into time series problem. So those problem, if we cannot solve in image processing domain, we can convert them into time series domain and then we can solve. So this is one project which we did for TVS Motor Company long back in 2007, 2008. They were manufacturing TVS sports bike. So what is happening? There is an engine of a two-wheeler, and operators were testing that engine. And what was the problem with them? They were selling this particular bike in the market, and then if there is a problem in the engine, people were complaining, customers were complaining, and then they have to put lots of money into the investigation, and then they have to bring these particular bikes back, and then they have to compensate the customer, and then the customers were actually telling 10 more peoples that not to buy these type of vehicle from TVS. Okay, so then they came to us, and then we have designed this system for them, and the system we have installed at their TVS Motor Company Hosur. There is a manufacturing unit. So what we did, we have used multiple microphones. So mics are there. So definitely, if we are starting the engine, if we can detect the sound of the engine, and based on the sound of the engine, we can classify whether the engine is good engine or not good engine. So initially, they have asked us to detect if it is not good, then we can also predict if the type of fault in that. So what we have observed that they have requested us for 4 types of fault, but we have given them 6 type of faults. Okay, so now you can see that this is a time series data set. This was the test rig. So what is happening during the manufacturing? There are lots of engines coming to this particular section. They were putting all these engines on the test rig, checking, putting the fuel thing, starting this engine. Then operator was listening the sound of this engine, and then based on that, he was deciding whether it is good or not good. So now what we are doing, we are actually using microphones. Microphone based, we are capturing the acoustic signal of the engine, and then based on that, we are making the decision whether engine is good or not good. Okay. Okay, so you see there is a computer system here. Later on, what we did, we have actually used a touch screen based system, and then there is a printer installed with this. We can take the printout, the health condition of a engine, and then we can put a sticker. And this was the interface, like we can detect whether the engine is good, engine is not good, and if it is not good, what is the possible type of fault, like cam chain noise, magnetorotor noise, primary gear whining, tappet noise. And then at the same time, we have also told them that there are some good engines and then there are some very good engines as well. Okay. So what they have observed, that they were mentioning that a particular bike is having a mileage of suppose 80 kilometers per liter, but then they told that now they can understand that there are some very good engines, and that's why some of the customers were reporting more mileages than whatever they have claimed. Okay, so that was the reason, even they were not knowing that they are producing very good engines as well. And now you see that the system is installed at TVS Motor Company assembly line and is working satisfactorily. TVS Motor has acknowledged this as one of the best project ever implemented by them. Okay, so our partners were IT Kanpur and IT Delhi also along with us. This is another example of Panna National Park, Madhya Pradesh. So what we have done for them, there is a forest in the Madhya Pradesh. Okay, Panna National Park, lots of tigers are there. So what we wanted, that poachers normally get inside the forest and they used to kill the animals. They also sometimes what is happening, the tigers and other animals were also going from the forest to the nearby villages and also killing the humans as well. Okay, so what we did, we have actually used multiple electronic modes, the sensors, so that we can detect if there is a gunshot in the forest or not. Okay, so these electronic modes are the wireless kind of device. So nowadays we say them Internet of Things. So this work we did in 2013 to 15, but nowadays people talk about the Internet of Thing. Okay, so everywhere we can actually deploy sensors, and then those sensors will have different kind of capabilities in order to detect a signal, in order to record some signal. Okay, now you see there are lots of antennas. You can see is the electronic mode. Ohio State University has actually developed these modes, so which are having microphones installed in it. So now we are having microphones located at different places with a battery, and then if there is a gunshot, we can actually get signal from multiple electronic modes. Now we are getting multiple electronic mode signal. Now based on that, we can detect whether there is a gunshot or not. If there is a gunshot, we should be able to locate that particular location where exactly this has happened. Okay, so this was our problem. Second problem was, if there is a tree cutting happening inside the forest, we can detect. If there is a gunshot happens, and then there will be some roaring sound of animals that will also be there, so we can actually track them. We have also designed one virtual fence for this forest, so that whenever some animal is crossing a particular boundary, we can detect that animal is crossing from forest to village, as well as if poachers are crossing that particular virtual fence, then we can also detect if it is human. Okay, so you see, there are different kind of behavior that rifle in the open ground and rifle near water flow. Okay, so same thing, but the signals are different. Okay, shotgun in the open ground, shotgun near water flow. Okay, so we were also testing the communication level, like how far we can communicate using these electronic modes. And we have found that if there are no lanternas, then we can communicate around 2 kilometer. But finally, we have deployed our system 200-meter apart. Okay, so one electronic mode, then 200 meters, second electronic mode, something like a grid. So you can see there are lots of our students are there, forest guards are there. We were collecting the data set for gunshot. Okay, right hand side you see this was the elephant we used to go inside the forest, and we have to put electronic mode on these trees. Okay, so that people should not be able to take away, and that's why we have to climb up on the tree, and then we have to put the sensors there. You see, I am climbing on the tree and then putting the sensor. Okay, so sometimes this was also happening that our students are getting inside the forest and tiger come. Okay, then they have to deal with such situations as well. But these were the elephants, they were taking care of us. So this is another place, that is Chhatbir Zoo in Chandigarh. So we have also collected the data set for virtual fencing. So what is the concept of virtual fence? There is a fiber optic cable we are putting beneath the earth around 1 feet. You see, we are digging it, and then we are putting fiber optic cable. You can see there is a yellow kind of wire going on. So single fiber optic cable, and then we can put below earth around 1 feet, and then we have to again put soil back. Whenever somebody will cross it, we'll capture the pressure in form of the fiber optic signal, and then based on that we can detect whether it is human, animal, or whatever. So you see, if there is a tiger, will have different kind of pattern. If it is human, it is a different kind of pattern. If it is elephant, it's a different kind of pattern. So we can easily detect whether it is human has crossed, elephant has crossed, or tiger has crossed. Okay. So these are some of the examples where you can understand like how this time series are useful. What are the practical scenarios? Okay, where this time series is there. So everywhere, whenever we talk about the real-time monitoring, you'll see all these kind of examples. You'll see the example of time series. So you see two pictures. They are looking like very similar. The quality or state of being similar, like resemblance as a similarity of features. That is the Webster dictionary. So similarity is hard to define, but we know it when we see it. So that is the important aspect here. That when we know it, when we only know it when we see it. Okay, but it is very difficult to define. Similarly, if there are time series signals, and if we have to find out whether they are similar or not, it is very difficult problem. Okay, so the real meaning of similarity is a philosophical question. So now coming back to the original data set which we have created for that hysteresis curve, like input 1, input 2, input 3, and then output. So now if we are having the regression formula, we can have y is equal to a1 x1 plus a2 x2 plus a3 x3 plus a4. Okay. Or if we are having a neural network basic machine learning algorithm, so we can have three neurons in the input layer, one neuron at the output layer. In between, we can have multiple hidden layers, and then we can train this model and then predict for the future. Then the era of deep learning came. Okay, so we use concept of convolution. I will not go into the much detail of these deep learning algorithm. So what is happening when we were working with the machine learning technique, we were making first our data set into good quality data set, then we were learning using machine learning algorithm. So first we were doing feature extraction, then we were doing learning. Now in the era of deep learning, what we are doing both the things together. So first, initially, we are doing the feature extraction, and then at the same time, we are also doing the learning. So what is happening if we are using this kind of system? They are producing much better result as compared to the basic method, because feature extraction we are doing at the same time. Okay. So like this is one example of the feature extraction using a filter. That this is the image. Right hand side, we are getting only the horizontal output from this image. So from where we are getting this horizontal image, from the first filter, you see there is a horizontal line filter, -1, -1, -1, 2, 2, 2, -1, -1, -1. So if we are using this filter, we'll get only horizontal line. If we are using second vertical line, so we'll get only vertical line. So it means we are using multiple filters for the same image, and we are generating different filter outputs. So we are actually scaling up the dimension. Then what we'll do, we'll scale down and then we'll do the learning. So in different angles, we are capturing the features and then we are doing the learning, and that's why our deep learning models are performing very good. So we have created a particular model using the deep learning method, and then we did the classification, and based on these benchmark data set, you see in most of the cases our algorithm is producing very good result. Okay, so these are some of the benchmark data sets available at UCR repository. You see we have compared our this deep learning algorithm with them, and most of the time we are getting very good result. But for faces, all faces, UCR and lighting too, we are not getting very good result. Then we have updated our model, time series model, and we have added some concept from the real biological brains. So we have used spike encoding, and then after the upgrading this, so there are multiple publication also associated with this type of work, like CLR based deep convolutional spiking neural network validation based stopping criteria for time series analysis and classification. So you can find out all these papers also where you can get other details. So you see if we are using different filters, we are getting different kind of outputs also. Okay. And what we have observed, that almost all the cases we are getting 100% accuracy in the time series modeling. So even better than whatever is best algorithm that exists in the world. Okay. So that's what was our work, which we did during the era of this deep learning modeling. Okay. And then we have applied on our algorithm on the multivariate time series data set, and what we have found that in most of the cases our algorithms are performing very good as compared to any other existing algorithm. And after that, this era of generative AI came. So now what is generative AI? That can generate data set. You must have heard about transformers. You must have heard about large language models. So what is happening? Whatever is the data set that exists in the world, people have tried to learn from those data set, either structured or unstructured, and now they are able to answer the queries whatever you ask from them. Okay, so like chat gpt is there. What they have learned, they have learned their system based on whatever data set exists in the world, based on text data set, images data set, speech data set, and now they are able to produce output. So there is a company known as Nixtla. So what Nixtla did, so they have used all type of time series data set in order to train their transformer model, like finance data set, electricity data set, web traffic, retail data set, tourism data set, internet of things data set, healthcare data set, transport data set, economics data set. So you see all these the example of time series data set. So now what they did, They have trained their transformer model on all possible time series data set in the world, and now they have designed and make this time GPT. So that is known as time GPT. Okay, so like chat GPT is for chatting, textual thing. Time GPT is for modeling and using this time series data set. Okay, so they have created this time GPT model, and you can use them freely. Many companies have also started using this time GPT model in order to model time series and do the prediction. And the important point is, up till now, what we have seen like we have to represent it in a different format, time series data. If we are working with deep learning, we have to make a model, and then we have to do some kind of feature analysis, and then we have to do the learning. But when we talk about this generative AI time GPT model, what we have to do, we have to just give upload our data set, and it will immediately start predicting for the future values. So that is the strength of this time GPT. So only 3 lines of code is required in order to model any time series data set. Okay. So there is a video also associated with this. So I will not play it, but I will share this link so that you can go through it. It's a small video so that you can see how to work with this time GPT. So you have to log in at Nixla, you have to register there. So they will give you some kind of token, and that token, in the first line, you have to read that token. Second line, you have to upload your data set, and third line, you have to just predict whatever you want. Like you want prediction for 24 hours, you want prediction for 3 days, you want prediction for multiple time series data sets. So all the things can be done together. And now they have also updated so that you can work with this time GPT model in distributed environment as well. Okay. So I'm also their official reviewer of this time GPT model. Okay. So I'm not playing it, but you can later on read it, how we can use it. Okay.
And uncertainty as future outcomes.
Okay, you see here there is a line, 1 line of code.
They'll show you interesting. Eh, I really need time series. But
You see this. So there is a line number 10. Time GPT is equal to time GPT OS environment, and this is the token which you will get after registering at their website. Second line is loading your historical data set for which you want prediction. So historic df pd.read csv, you have to just upload your csv file. Third line, predict the future. Forecasting, time GPT forecast historic df h is equal to 24, means next 24 data set. Okay. If you want to find out anomalies, you have to just give find anomaly. Okay, immediately it will detect the anomaly. Okay, so at the multiple time series data set, you can use this model. You see there is a yellow part here at the end, which is the prediction for the future. Okay, and we can also detect if there is the anomaly. Okay, so in this picture it is not very much clear, but later on you can see that it is very easy to use this time GPT model in order to detect and predict, detecting the anomaly, predicting for the future values, and very quickly as well. So what are the concerns? Lots of dimensionality data leading to big data is the major concern. Fusion integration complexity is there. Multiple sources are there, and we have to collect data set from the multiple sources, and then based on that we have to make decision in real time. So real time decision making, control and forecasting is very important. So modeling in distributed environment and predicting in real time is the need of the hour, because if we are not predicting in real time, it will be very difficult to use this any type of model for any real life problems. Okay. Security and privacy is definitely a major concern, because if you are dealing with this type of data set, you should also address security and privacy as well. So question is, why can't there be a better way? It start not with data analytics, but an idea or a question. Okay, so like you have seen the toothbrush. So there is some idea, and now you can convert that idea into the product. Okay. So thank you. I am only one, but I am one. I cannot do everything, but I can do something. and I will not let what I cannot do interfere with what I can do. Edward Everett Hale. Okay. So whatever you can do, you should contribute. You cannot do everything, but you can contribute something in some form so that it can be useful for anyone. Okay. So nowadays, we are working with the VPN detection project. So we are analyzing the network traffic data set in order to detect whether people are using virtual private network or not. So there are lots of security related issues, and we are applying this time series there also. Okay, so it's a huge project, about 5 crore rupees from Ministry of Electronics and Communication Technology. And if we are also working with robotics as well. So we have all the latest robots at our lab. So those who are interested are always welcome to visit our lab anytime. If they want to do something with us, they can freely come to us. They can contact us. Okay, you can get all the details from Dr. Vibhas and others. So you are always welcome to reply to Allahabad. You can spend time. Those who are research scholar can also get guidance, some help from us. So whatever is possible, we will do all the needful. So thank you so much. Thanks from our deep learning lab as well. Thank you.
Thank you so much, sir, for this highly valuable session. Is there someone for any feedback?
So any questions if you want to ask, you can ask.
Even someone wants to give some feedback, then he or she is most welcome.
हेलो विजय सर, नमस्कार। मैं डॉक्टर सुधाकर त्रिपाठी REC
नमस्कार
सर। बहुत अच्छा था, मतलब सेशन मैंने पूरा सुना। टाइम सीरीज में मैं पार्टिसिपेंट से भी कहना चाहूंगा कि मैं खुद जब बताता हूं, जबकि हम लोग खुद काम करते हैं, सर ने जितने सिंपल तरीके से डाटा सेट की, भाई आपके पास एक सिंपल लिनियर डाटा सेट है, कैसे टाइम सीरीज आप जनरेट कर सकते हो बेस्ड ऑन हिस्ट्री, कितने स्टेप्स तक इनकैप्सुलेट कर सकते हो, सर ने जितने सिंपल तरीके से बताया, इवन 12th का बच्चा भी अगर उसको इम्प्लीमेंट करे और आगे जाए बहुत अच्छे से कर सकता है। सर को मैं पर्सनली जानता हूँ, हमारे IIIT प्रयागराज में मशीन लर्निंग AI का इम्प्लीमेंटेशन, और सर के यहाँ फॉर्चुनेटली इतने डाइवर्सिफाइड एप्लीकेशंस डोमेन है, इंक्लूडिंग बायोइन्फॉर्मेटिक्स, मेडिकल, अप्लाइड केमिस्ट्री से बहुत अच्छा काम होता है। तो रिसर्च स्कॉलर्स से मैं या जो भी स्टूडेंट्स या फैकल्टी मेंबर्स जो सीख रहे हैं, प्लीज गो थ्रू इट। मैं खुद सर को फॉलो करता हूँ, या जैसे आज बिलफुली मुझे 15 मिनट छूट गया, उसके बाद भी मैंने विभाग से कहा कि अच्छा यूट्यूब पे है तो लेक्चर देख लूंगा। हम लोग जानते हैं, लेकिन वी गेट डिलाइटेड, क्योंकि देखिए कठिन तरीके से तो सब जगह अवेलेबल। आप स्टैनफोर्ड की यूनिवर्सिटी पे जाएंगे, ICW पे जाएंगे, MIT में भी, लेकिन एक जो लेमैन, एक बिगिनर्स के लिए जो स्टार्टिंग है टाइम सीरीज, अब आप किसी भी फैकल्टी से, हम लोगों से भी रैंडमली पूछिए, तो शायद हम इतने सिंपल तरीके से ना समझा पाए, या बता भी देंगे तो वेग डेफिनेशन कि हाँ ये टाइम सीरीज ऐसे आता है, बट एक्चुअली डाटा हमें ले कैसे जाना है, कितना करना है। अगर हमारे पास एक ही डाटा, भाई 20 साल का डाटा है फोरकास्टिंग का, और हम कैसे आगे उसको इनपुट आउटपुट में जाएंगे, क्योंकि मॉडल तो हमारा आज भी प्रेडिक्शन मॉडल वो लेगा टेबुलर फॉर्म में क्लासिफिकेशन। तो इट वाज रियली वेरी गुड। और मैं सर का अगर PPT प्रोप्राइटरी ना हो या यूट्यूब
नहीं, मैं शेयर कर दूंगा, मैं शेयर कर दूंगा,
शेयर कर ले तो इट विल बी बेनिफिशियल फॉर ऑल फैकल्टी मेंबर्स, क्योंकि मैं
हम
हमेशा
सारे
मशीन लर्निंग
PPT
AI
सब
में
लोगों से रिक्वेस्ट करके लेके और सबको शेयर करेंगे।
क्लाउड कंप्यूटिंग प्रोजेक्ट्स,
क्लाउड कंप्यूटिंग आई एम नॉट करेंटली वर्किंग, केवल एक चीज।
ओके, थैंक यू सो
और
मच।
लोगों को उस पर ध्यान देना चाहिए। क्लाउड कंप्यूटिंग में कोई कर रहा है तो ऐसा नहीं मैं उसे डिस्करेज कर रहा हूँ, वो अच्छा काम कर रहा है डेफिनेटली, और उन लोगों में होगा जो बहुत कम लोग हैं जो काम कर रहे हैं, लेकिन फिर भी ये ना कि आजकल जो इन्वायरमेंट चल रहा है वो सब इसी का चल रहा है।
IIT पटना में सर 1-2 ग्रुप है, मिश्रा सर का ग्रुप है IIT पटना में, वो सर का ग्रुप थोड़ा बहुत काम कर रहा है उस पर, कुछ एक पर्टिकुलर
नहीं,
डोमेन।
बाहर लोग कर रहे हैं, हमारे हम अपने इलाहाबाद की बता रहे हैं
जी
तो यहाँ पे अभी तो नहीं कोई कर रहा
चलिए
है।
एक क्वेश्चन कोई और भी आया, देखो।
Yes, sir. The question is how different data set are combining in machine learning models.
तो वो डिपेंड करता है किस प्रॉब्लम को आप एड्रेस कर रहे हैं, ठीक है, तो उसके हिसाब से उसे ऐड करना पड़ता है। मतलब समटाइम्स वी आर आल्सो कंकैटिनेटिंग द डेटा सेट, ठीक है, कंकैटिनेशन इज नॉट वेरी गुड, बट कुछ केसेस में हमें कंकैटिनेट भी करना पड़ा, हेट स्पीच के केस में, है ना। तो वो मॉडल पे और डेटा पे डिपेंड करता है कि किस टाइप की आप प्रॉब्लम सॉल्व कर रहे हैं, उसके अकॉर्डिंगली वी हैव टू कंबाइन द डेटा सेट। ठीक है, स्पेसिफिक कोई प्रॉब्लम है देन आई कैन क्लियरली आंसर, so it will be problem to problem.
Okay, then moving toward the conclusion session, I would like to invite Miss Neha Sankhwar ma'am for the vote of thanks.
Hello. Hello.
Ma'am, you are not audible.
Hello.
Audible. Yeah.
Good afternoon, everyone, and good afternoon, sir. So, on the behalf of Department of Information Technology, Rajki Engineering College, Banda, I would like to sincerely thank you, sir, for delivering such a knowledgeable and engaging session. The way you connected the real-world applications and ongoing projects of time series analysis has given us a broader perspective on the topic and made the session easy to understand and highly informative. You also explained the way generative AI can be used to analyze time-based data, make accurate prediction, and support better decision making in the field. And also, thank you, sir, for the story that you told in the starting of the session. So, thank you all the participants for their active participation, and thank you, sir, once again for the
थैंक यू
session.
मैडम, थैंक यू सो मच.
With
तो
this,
आप मुझे विभाष जी लिंक भेज दीजिए, तो मैं उस पे मतलब मेल भेज दीजिए, उस पे मैं आपको डॉक्यूमेंट भेज दूंगा.
Sure. Thank you, sir, for your precious times.
थैंक यू ऑल द बेस्ट. थैंक यू. प्रणाम.
Students, sorry, participants, we have shared the feedback and it will be open till 4:15 p.m. So all of you are requested, please fill the feedback and we'll meet tomorrow at 10:15 a.m. Thank you.
Thank you, sir.